Okay, good evening to all. So we will see in the yesterday's lecture, we have seen the topics, that is diffusion, absorption and drying. Okay. So today we are going to see the most important topic, that is the distillation. This is the most favorite topic of GATE examination. Means you will always see one question from this part. Okay. You will always see one question from this part. Okay. So you have to make sure that in this part you will not make any mistake. Okay. So in this, question will be from the batch distillation. Okay, batch distillation. So from batch distillation, you have to remember the one formula. Log f xf upon w into xw is equals to a relative volatility log of f1 minus xf upon w1 minus xw. Okay, this is the thing. So if you solve one question from this part, okay, that is 100 moles of binary mixture feed contains 60% mole of A, that is more volatile, and 40 mole percent of B is heated in a batch distillation okay. After 1 hour, 70 moles of distillation is in distillate, leaving behind the residue. Okay, and the alpha value is given 2. So relative volatility. Okay, so relative volatility. Okay, relative volatility means basically how much they will be volatile with respect to each other. Okay, so that is the meaning of relative volatility. Okay, so here if we see, we can use this because here they have done the one type of batch distillation. So you can use formula 100 into 0.6. This is the formula. Okay, 100 into 0.6. You can remove this log. Okay, upon here, what more data is needed is that we have to calculate the average mole fraction of A in the distillate. Okay, we have to calculate the average moles. So here 70 moles in distillate. So it will be 30 into xw. Okay, remaining will be in the residue. It is equals to 100 upon 30 whole square 1 minus 0.6 whole square. Okay, upon 1 minus xw whole square. Okay, this is the thing. On this, what answer you will get? It will be 2 upon xw is equal to 1.77 upon 1 minus xw whole square. Xw equals to 0.4028. Okay, F into XF equals to D into XD plus W into XW. Okay, so it is 100 into 0.6 equals to 70 into XD plus 30 into 0.4. You can easily calculate the XD value. How much it is coming? It will come 0.6841. So that has been asked in the question. Mole fraction of A in the distillate, that is the value of XD. This is a very easy question. Okay. Okay. One more question. The vapor liquid equilibrium curve of a binary mixture may be approximated by a linear equation of or a range of liquid mole fraction. Zero 0.2, 2x, 0.3. And the relation is given y star is equals to 1.325 xa plus 0.121. Okay. Feed is 100 mole. XAF is 0.28. XW is 0.2. So you have to use Rayleigh's equation. Calculate the numbers of moles of a residue left behind in distillation. Okay. So it will be ln F by W is equals to, range is given 0.2 to 0.3 dx. It is y star minus x. So what is the value of y star? 1.325 xa plus 0.121 minus xa. You can directly, feed value is also given. How much feed value is given? This feed value is 100. So you can easily calculate the W. What is coming? It will be 66.85. Okay. Okay. Next is the MACAP method, which is very, very important from the gate point of view as well as from the interview point of view. Okay, so here one simple question we will do. For a two-phase feed value where 80% of the feed is in vapor, slope in MACAP method for a distillation design is so slope of feed line is Q upon Q minus 1. What is Q? The most important thing is Q always gives idea about liquid. It does not give idea about the vapor. So in the question you see they have 80% of feed in the vapor, but Q is liquid, so it will be 0.2 upon 0.2 minus 1. So it will be 1/4 like this. Okay. Next is the Fenske Underwood equation. It is used to calculate the number of plates. Nm plus 1 equals to ln xt upon 1 minus xt 1 minus xw upon xw upon ln of alpha average. Okay. So here one will include that it is including boiler. Okay. So let's solve one question. So in the gate examination, this is the favorite topic, distillation. So from the distillation, actually there are some simple questions are also coming. Okay. So here, according to Fenske equation, what will be number of plates required in a distillation column to separate equimolar binary mixture of component. A and B into an overhead fraction contain 99% moles of A. Bottom fraction contain 98 mole percentage of B. Alpha AB is equals to 2. So here Nm plus 1 is equals to ln 0.99 upon 1 minus 0.99. Okay. because it is 99%. And the bottom fraction contain 98% of B, but we want A. Okay, so A will be 1 minus 0.02 upon 0.02 upon ln of 2. So now Nm, calculate the value of Nm. So Nm is 11.5. So that is why we will do 12 plates. Okay. So again, this is a very important. Just you have to remember the formula and you will directly get the answer. Okay. So that is why you have to grab such questions. Okay. So it will be very, very easy to solve such question. The point is you have to remember these formulas. Okay. That is very important. Else it is very easy question. Next question. A binary feed mixture contain equimolar quantity of S and T is to be distilled in a fractionating tower at atmospheric pressure. The distillate 96 mole percentage and Q line intersect the equilibrium line at x dash equals to 0.46 and y dash equals to 0.66, where x dash and y dash are mole fraction. Assume that the McCabe-Thiele method is applicable as the relative volatility is constant. So you have to calculate the minimum reflux ratio. And you have to find out the condition of the feed. Dew point, bubble point, superheated vapor, and D is it is partially vapor. Okay, let's solve. So here just I will explain the concept also. Like this, it is a graph. So here you have a feed line. Okay, so this is distillate. It will be like this feed line. It will intersect and this, like this. Okay, so we have to find out these coordinates. Okay, so here they have given that it is 0.96, 0.96. Okay, and the slope of this line is what is the slope? It is Rm upon Rm plus 1. It is the slope of a distillate line. Okay. What is R? It is reflux ratio, L by V. Okay. Slope here is L by okay. Like this. It is a minimum reflux ratio condition. Okay. And here it is Ln by Vn plus 1 into Xt. So solve this. And the reflux ratio is L by D. So when you calculate slope here, it will be y2 minus y1 upon x2 minus x1. What is the slope is coming? Calculate this 0.6 because coordinates are given 0.96 minus 0.66 upon 0.96 minus 0.46. So Q equals to 0.6. So you can calculate the value of Rm. It is 1.5. Okay. Now you have to calculate the feed quality. Okay. Now you have to calculate the feed quality. So how will you calculate this? See, Q. I have told what is Q. Q will tell regarding the quality of the feed. Okay, so if Q is coming 0.6, what is the meaning of this? Okay, if Q is if Q is going 0.6, it is partially liquid and vapor. So these are the common questions which are frequently asked in the GATE examination. Okay, so please be comfortable with this slope of the upper operating line, slope of the, you can say, downward. Okay, so distillation column is divided in three parts. This is distillate, this is residue. So what is the slope of residue? This, you should be very, very comfortable with this slope of the feed. There are so many questions in this. Distillation column separates 10,000 kg per hour of benzene, toluene mixture as shown in the figure. Okay, so in the figure, XF, XD, and XW represent the weight fraction of benzene, the feed residue. Here the diagram is given. It is 8,000. HD equals to 0.95. XW equals to 0.05. XF equals to 0.5. It is 10,000. Okay, so you have to calculate the reflux ratio. Calculate this. Okay, so how we will solve this question? So here 8,000 is going here. Okay, and how much is coming? So here it is 10,000 of 5, means here it is going 5,000 distillate, and here it is, so R is L by D. So how much liquid is going? 8,000 minus 5,000 is equals to 3,000. So here it will be 3,000 divided by 5,000. Will directly give you 0.6. This is the answer. Because we know V equals to L plus D. We have liquid and distillate is there. How much vapor is there? Is there in the question. Okay. So such questions are frequently asked. Okay. Let's solve one more question to have more comfortable from the distillation, because distillation is very important. You can't means effort to skip this topic. It is very, very important. A binary distillation column operating with a mixed feed contain 20 mole percent vapor. If the feed quality is changed to 80% vapor, the change, the slope of Q is. Okay. So here you have to calculate the value of delta Q. Okay, so here it will be Q2 upon Q2 minus 1 minus Q1 upon Q1 minus 1. So here you will directly get minus 3.75. That is the change. Okay, it is directly given. It is 20% vapor means how much liquid is there? 80% vapor means 20. That's it. Okay, you can directly put the values. 0.8 upon 0.8 minus 1 minus 0.2, 0.2 minus 1. So it is 3.75 minus. Okay, so in this way, there are number of distillation portions which can be easily solved. Some important points you should remember: for minimum reflux ratio, infinite number of stages are required. And if you increase the reflux ratio, what will happen? Load on reboiler and condenser will increase. Okay, so that is why you have to use optimum reflux ratio is 1.3 to 1.5 of R. Okay, and the most important thing is the lines we should remember here. Okay, so here Q is equals to 1, here Q is greater than 1, here the Q is in between 0 to 1, here Q is 0, here Q is less than 0. Okay, so this is important. So if 1, it means it is a saturated liquid. Saturated vapor if it is 0. In between means in between liquid and vapor. Greater than 1 means cold feed. It is superheated vapor. So this will give you the data regarding the position. This will give you the data regarding the position. Actually, this will give you. Okay, it means that if in the feed, if it is very cold feed, then it will come. Okay, then it will come from the upper part. Okay, then it will come from the upper part. Okay, that feed should go from the near to the distillate. Okay, because when it will come down, then the mass transfer will take place between the liquid and the vapor. That is why it is very important to have a correct position. Okay, to have a correct position of a feed. Okay, if you have a correct position of a feed, then only the separation. Okay, then only the separation will takes place in a correct manner. Okay. Here Q is basically HV minus HF upon HV minus HL. So basically H is enthalpy of a vapor, feed, vapor, liquid, saturated liquid. Okay. In a single stage extraction, process 10 kg of pure solvent S containing no solute is mixed with 30 kgs of feed containing A. At a mass fraction of XF equals to 0.2, the mixture splits into a extract phase E and raffinate R. Containing XC and XR is equals to 0.5 and 0.45. So you have to calculate the total mass of extract in kg. Okay. So in liquid extractor, basically there is a substance, there is a solvent. Okay, here you can say feed, and there will be extract, and there will be raffinate. Okay, these are the important things in the feed, in the solvent, in the extract, and in the raffinate. F plus S equals to E plus R. 30 into 0.2 plus, it is a pure solvent, so that is why it is 0. It is E into XF plus R into XR. So now we have to calculate the value of E. Now you have to calculate the value of E. Okay. So here we have a data 30 plus 10 is giving E plus R. Okay, 30 plus 10 will give you E plus R. And another equation we have 6. Okay, 30 into 6 is equals to E into 0.5 plus R into 0.05. So from here we can easily calculate the value of E, that is approximately 6.86 kg. So what is important from the gate point of view is that only this thing you have to remember, that extract is there. You can easily do the balance. Okay, if you know the material balance basics, you can easily do this. Okay, you can very easily do this. Okay, so this is from the extraction part. Okay. Now we will see one adsorption question. Okay, so this topic is not frequently asked, but sometimes they ask. Okay, because we have seen first absorption, AB means there liquid and gas mass transfer is taking place, but here solid liquid we can say mass transfer is taking place. Okay, so an adsorption on activated carbon is to be used for reducing phenol concentration in wastewater 0.05 mole per liter to 0.008 mole per liter. The adsorption isotherm at the operating temperature can be expressed Q equals to 0.025 C 1 by 3. Okay, where Q is the phenol concentration in solid, that is mole per gram solid, and C is the phenol concentration. In mole per liter. So we have to calculate the minimum amount of solid required. The minimum amount of solid required per liter of wastewater. Okay. So see here, adsorption is going on once there is a phenol, there is a solid. Okay. So how much phenol is to be absorbed? It is from 0.04. It is up to this. How much? It is mole per liter. In 1 liter, it is 0.032 mole. Phenol is to be absorbed. So we want a relation is given 0.025 C to the power 1 by 3. Okay. And the C reduced phenol is how much? Where up to which point we have to go? 0.008. So Q equals to 0.025 into 0.008 to the power 1 by 3. So how much it is coming? 5 into 10 to the power minus 3. So activated carbon required. It is equals to 0.032 into 1 upon 5 into 10 to the power minus 3. Okay, so it is 6.4 gram. So this much amount of activated carbon is required. Okay. So there is a one good question. Okay, so we have covered almost all the topics, one question. So the most important topic that you can't skip, that is distillation and diffusion and absorption. Every year you will find 5 to 6 marks question from this part, and they will be easy. Okay, not too much difficult. It will be very costly to you if you skip this topic from the mass transfer. Okay, so we'll take one last question from the drawing. You will say there is a direct formula based or conceptual based question. So one question we will see in the drawing of non-dissolving solid at constant drying condition, the internal moment of moisture in the solid has a dominant effect on the drying rate during option A, the initial adjustment period, the constant rate period, the falling rate period, both the initial adjustment and constant rate period. Okay. So there is an interesting graph from the drawing section. You should remember this actually. This is unbound and this is constant rate period. Then there is a fouling. Then this is their X star critical. Okay. And this is known as unbound. And this is bound. Okay. Here it is free moisture content. Okay. So this is the thing. If you see this question, what is told in the drying of a non-dissolving solid at constant rate drying condition, the internal movement of moisture in the solid has a dominant effect on the drying rate during. Okay, the initial adjustment, no. The constant rate period only, no. The falling rate period, yes. Okay, so falling rate period, there will be internal movement of moisture has a dominant effect. Okay, so this is falling rate period. Okay, so option C is correct. Falling rate period. Okay, so see, such easy questions will be asked from the drawing, and the most important topics from where easy as well as some difficult question will be asked. Okay. Okay, so basically you cannot afford to lose marks from these topics. Okay, it is very, very easy. Okay, so that is the thing. So please cover this topic. You will definitely score a very good marks in the mass transfer. Okay, and some easy questions will always be there from the drawing part and all that. Okay, so please make sure that you have done a very good practice. Okay, and all that, and this will help you in the gate examination. Okay, so that's it for today. Thank you.